Got some helmet here going on. It's okay. That's why bad scientist look. You have to deal with it. Hello, YouTube. It's Saturday, December 26th. And I'm going to do something a little nerdy here. Going to science nerd out on you here. And I'm going to talk about terraforming and the implications of terraforming vis-a-vis the onrush of global climate change, right? So this is something that occurred to me a couple of days ago. I was realizing, oh, yeah, imagine that. How funny, how ironic. Maybe I should do a video. So here it comes. This is very scientific, very science fiction-y, very technical. I'm going to use a lot of big terms here. I'll try to define them as I go, but this is raw science. Okay, this is straight up science. This is systems ecology, system science, and it really doesn't get any more nerdy than this. Okay, in my field. So here we go. So terraforming. Now terraforming is a term. Terra means earth. Forming means to shape, to make like. And the idea for terraforming, to take a planet or a moon or any other body and make it Earth-like, came to us from science fiction, early science fiction. So many decades ago, people were speculating about our ventures, our tentative steps into space, where that might go. People were writing, the golden age of science fiction, writing about rockets and faster than light travel and strange worlds and alien worlds and travel along the stars and these kinds of things, and all obviously very speculative, but fun to read. Terraforming comes to us via science fiction. Somebody was writing about, obviously, colonists finding a planet and deciding to make it Earth-like. So what does that mean? So this is not necessarily something people can do. This is highly speculative. It's something people would probably want to do. So if we want to do it, maybe we find a way to do it, right? It does come up in some conversation circles, like we're going to go to Mars, but are we going to terraform Mars, turn the whole place into a habitable planet for humans? Or are we going to, it's called para-terraforming, where you just terraform a piece of it, like under a dome or some other type of protection, and you terraform a piece. It could even be a really big piece. It could be a series of domes that can cover, thousands of acres. So we're on Mars, we're probably going to terraform part of it. And what's that going to look like? Well, the term comes from science fiction, as I said, and it is the approach. It's not really a method, because you'd have to make up your own how you want to do this depending on your situation, but it's the approach of going to another celestial body, a planet or a moon, and deliberately applying chemistry, engineering, whatever, to making it more like Earth. So if the atmosphere doesn't have much oxygen in it, then to make it more breathable for us, you would bring in some sort of photosynthetic process, algae or plants or something, and have them generate oxygen and make the atmosphere more breathable. Great. If the planet is all water and lacks land, well, that's not going to work for us. That's not our favorite way of doing things on the water all the time. So maybe you dredge up from the depths and pile it up into seamounds and raise up the level of the seamounds until they appear above the water. Now you have land. Okay, so this is terraforming, changing things to suit us, our needs, our preferences. And never mind that it sounds silly. It's people are talking about it, right? So I was thinking, oh yeah, right, terraforming. That works both ways. And here's how it works both ways. So the Earth, as you know it today, and I know it today, and all of us experience it on a daily basis, is just one version of this Earth. It has gone through quite a few changes. Some of the regimes lasted a long time. There were times when the Earth was very cold, almost a snowball. They call it snowball Earth. There was a time when the Earth was extremely volcanic. Lots of volcanoes, lots of ash clouds, lots of volcanic, smokes in the air, obscuring the sun. There were times when the Earth was more like one gigantic hothouse, the same temperature from the equator to the poles, pretty much. And animals that you normally associate with the tropics, reptiles, amphibians, living at the poles, surviving there pretty well. Maybe their growing season was shorter than it would be, in Hawaii, but they had a growing season. They could lay their eggs, they could rear their young, they had food, and they survived there. So the Earth has gone through many changes. We were not responsible for any of the changes in the Earth dynamic system until the current one. The other changes were caused by meteor impacts, comet impacts, maybe periods of intense volcanic activity that may have spanned hundreds of thousands of years. The breakup of Pangea into separate continents that we have now. It changed the Earth, the ocean flows, and it disturbed how heat was distributed, and so on. So there's lots of things that caused the Earth to go through changes. One of the more recent ones happened in about the period where humans were evolving. The plants had been changing the Earth's atmospheric composition by removing and burying CO2. Now, what we call those buried carbon compounds, what we call them now is coal, crude oil, and natural gas. All right. Collectively, fossil fuels. They're fossils. Everyone should know what a fossil is, right? It's a plant or animal that has been buried in the ground, turned to stone, and you can now dig them up and study the bones, to study the shells and teeth and all these things. Well, these carbon deposits are the fossilized remains of plants. Plants are made mostly of carbon. So when you fossilize plants, the carbon is still there, right? Conservation of matter. Carbon is an element, cannot be either created nor destroyed. It can only be moved around. And when the plants are buried and they die, then the carbon is there. Wherever they fall, that's where the carbon is. These days, when a plant falls, it's attacked by all kinds of decay organisms, funguses, termites, various beetles, millipedes, things that live in the soil, attack the tree or the plant or the leaves or the branches or whatever part fell, attack those things and release carbon into the atmosphere as carbon dioxide, methane, carbon monoxide, other things. So these days, when a tree falls, it is pretty quickly if you consider the life of the tree, which might be 80 years, very quickly, like almost instantly, within a few years, that tree is already beginning to return to the atmosphere. So these days, it's a carbon cycle. But 300 million years ago, when trees were growing in profusion and being knocked down in gigantic hypercanes and things like that, being buried in huge numbers, that process kind of didn't work. The plants kind of had the planet to themselves. There weren't a lot of complicated organisms, and the trees would fall, be buried, and the carbon would stay in the ground, wouldn't be released back into the atmosphere. So the trees, through no purpose of their own, just the way the Earth was operating at the time, were burying carbon. Now, I said they were taking carbon from the atmosphere through photosynthesis to create their own tissues, wood, if you prefer, fibers. And when they were buried, the carbon was buried in the ground. It became mineralized, coal, crude oil, etc. So that's a pump. That's a pump. They're pumping carbon atoms out of the atmosphere into the ground. And that carbon dioxide was a greenhouse gas. It was a gas that trapped heat. So when you're pulling it out and burying it in the ground, if it's not being returned through some other route, which largely was not, volcanoes can pump some CO2 in the atmosphere, but it's really small compared to the amount moving around due to living things. Okay, the amount of mineral CO2 entering the atmosphere is measurable, but tiny. So the plants were very good at stripping this stuff out of the atmosphere. It ends up being buried in the ground. That was not their purpose, but that's what ended up happening. And the rate of return of CO2 back in the atmosphere was vanishingly small. So the plants were engaged in a kind of terraforming. Now, they didn't have a goal, but they were changing the planet Earth. They were changing it unintentionally, no goal, no motivation of any kind, but they were changing the Earth. And they made, if you want to consider the Earth they were existing in for 300 million years, 400 million years as Earth version 1, then they were responsible for creating Earth version 2. And Earth version 2 looked like this. With the CO2 stripped from the atmosphere and effectively buried, not called sequestration, it was buried. In terms of geologic time, it was buried. Not a couple of years, but for millions of years it was buried. Even hundreds of millions of years it was buried. So it was effectively gone. Through sequestration, they cooled the Earth and created a much colder and drier Earth. Now, this Earth 2.0 actually wasn't even conducive to plant life. It's dry and it's cold, right? So, yeah, you can have forests, different kinds, different types of trees, different types of biomes emerge. You can have ice fields that have tiny little scrub plants that pop their heads up for 3 weeks out of the year when the snow is spotty, and they grow a fraction of a millimeter, and then they get buried again under the snow. So you can have those kinds of biomes. We now call them permafrost, the boreal forest, ice fields. Nothing grows there, but it's a thing. It's an ice field. Well, you have penguins, right? In the south, you have penguins on the ice fields. They eat fish and so forth. So you can have life in Earth version 2.0, but it wasn't the same as Earth version 1.0. The plants sort of shot themselves in the foot, as the saying goes. They were just doing what plants do. They did it really well, and did it so well they changed the Earth. Okay. It was also during this time that humans found our predecessors, eventually to be what we call humans, found conditions suitable for what they did. So maybe it was detrimental to some types of plants, but Earth 2.0 was quite conducive to our way of doing things. Humans are descended from a line of primates called hominids that walk upright and have their hands free and do not swing from the trees. Okay, that's monkeys and other apes swing from the trees. Their hands are not shaped like ours. They can grasp things, but their hands are not really, they don't really work quite right the way ours do. They have these long hooked hands that are really made to hook over a branch, and you're just swinging through the trees like this, okay? Also, brachiating, which is what that's called, brachiating, essentially, it means arming. So you're arming your way through the trees, you're brachiating. So brachiating also is not conducive to tool use, right? So if you're swinging through the trees and you're using your hands for that, then you're not using your hands to carry a stone tool, a spear, a pointed stick, anything at all. You're not even necessarily, carrying very much food. Yeah, you killed something on the ground, you have it under one arm and you climb the trees and you hang from a branch, but you're not traveling with that food. You're not traveling with your tent and your domestic animals and your grains and your tools. To do those things, the things that set us apart from the other primates, you have to walk on your feet upright, and keep your hands free. Now you can pick things up, you can hold them under your arm, you can pick up a child, hold the child, you can go this way, you can hand things to someone else to carry. You can, you've got, these are free. So our predecessors were doing that already. Almost certainly living on the forest floor, maybe at the edge of the forest where there's not quite so much clutter, brush and whatnot. And we were maybe, venturing out onto the savanna to take what meat we could, staying kind of close to the trees because that's where we could escape from predators. But we were already walking on 2 feet and we had our hands free. So when the Ice Age came, and the Ice Age was several glaciation episodes. I don't know how many, 20 or something glaciations, pretty much on a regular schedule. I've talked about that in other videos, so it's really not important here. But the Ice Age began, and it continued. The Ice Age continued. Earth 2.0 was an icy planet. There was ice everywhere. There's ice on the highest mountains. There was ice at the poles. There was ice in the winter in many places, even if they didn't have it in the summer. There was ice in the winter. It could snow many places. Even if it didn't remain, it still could snow. It got very cold. So we had a lot of ice on Earth, and the sea levels dropped accordingly as more and more water was pulled out of the basins and put up on high places, mountaintops, and up on the poles and various islands like Greenland, or the islands north of Canada, Ellesmere Island, and the rest, is piled on the land. When it's piled on the land, it's not the sea. So sea level dropped, and because the seas were cold, that reduced evaporation of water into the air. And with reduced evaporation of water into the air, you have reduced precipitation, water falling out of the air, other places. So the whole cycle of evaporation, transport, precipitation, warm currents moving around and melting ice, all that stuff was broken in Earth 2.0. The plants themselves created these conditions, and the plants frankly suffered for it. There were lots of places plants used to be that they couldn't grow anymore. It's just an example of how you can change the planet out from under yourself, right? They did that. The plants did that. But in the process of changing it to their detriment, they created an opportunity for us. We were upright walking, tool using primates that were accustomed to living in the open areas because if you're walking, you're not brachiating over the forest floor clutter, right? Where also the predators are, right? Jaguars and lions and tigers and all that kind of stuff. Wolves. You're brachiating in the trees. You're not down there in the mix, but you're not using your hands. So we were down there, and we were because we were surrounded by predators, and we were predators ourselves, and we had to create tribes, and we had to learn how to make tools, and our big brains were made possible by a protein-rich, energy-rich diet, eating meat. And so when the ice ages came, we were well suited to escape from the forest and out onto the savanna, Earth 2.0 savanna. And there we evolved until the current day. So that's how we got started. That was the world that we evolved in. Okay. Now, fast forward 18,000 years to the present day, and we are, frankly, doing kind of what the plants did, but in reverse. We are terraforming the planet. We are digging up the coal, crude oil, and the natural gas that the plants sequestered as mineral resources. We are digging them up, burning them for their very valuable energy content, and releasing the resulting waste products, CO2 and water, into the atmosphere. And we've been doing that for a long time. We've actually been doing things like that, burning things like that for 100,000 years. Humans had fire maybe even 400,000 years ago. We didn't exist. Humans, Homo sapiens, didn't exist. Neanderthals and others probably had fire 400,000 years ago. We inherited that knowledge from them, probably just by watching our neighbors do things with fire. So there's a neat movie, by the way, called Quest for Fire, set in Neanderthal times. I just now remembered it. It's a good movie. It tried to depict the struggle to domesticate fire and the impact, the beneficial impact that had on us, and how that was a life and death situation, and whether you had that or not. I recommend it, Quest for Fire. So we've been burning things for a long time. We knew about wood and dung and grasses, and we were burning things for a long time. So we started this process of reversing the plant-mediated accumulation of carbon. We've been reversing this slowly, and you might even say experimentally, for a long time. But just recently, say in the last 200 years, maybe 150 years, we really got serious about that. We really got serious about, with the invention of the steam engine, we really got serious about burning solid fuels, because suddenly with the steam engine, we could do so much work with this stuff. Used to be you burned a little bit of coal in your fireplace to heat yourself, heat your house. But it wasn't real valuable other than that. It was valuable to forge, for forging metals, smelting, forging iron, and but these are not huge uses. The amount of coal you burn in a forge, creating armor or nails or knives, whatever, is really small compared to the amount of coal you use firing a steam engine. Okay, it's like 100 to 1. A steam engine uses 100 times more coal to boil water and move that 80-ton locomotive down the tracks made of iron, pulling 20 or 30 cars made of iron, moving all this stuff at reasonable speed takes a huge amount of energy found in a correspondingly large quantity of coal. So we really started getting serious about our solid fuels with the steam engine. And then we discovered the magics of crude oil and using that as a fuel, but a liquid fuel in this case. And we went from external combustion engines like the steam engine to internal combustion engines where the fire happens inside of a cylinder. So once we had these tools and we figured out that we could do so much work than just heating spaces or heating iron, we could do so much more work with these moving machines, turning wheels, turning belts, turning fans, driving transmissions. When we discovered that, then our consumption of these fossil energy resources really took off. And since then, since about 150 years ago, we have been terraforming the Earth for the second time. If we allow that the plants did something to the Earth when it was their planet, and they destroyed Earth 1.0 and gave us Earth 2.0, which is the planet we inherited, okay? It was conducive to our evolution. We accept that. That's the first terraforming event. The plants destroyed Earth 1.0 and made Earth 2.0, damaging themselves, but creating an opportunity for us. Now, the second terraforming event comes along. We're doing it this time. It's our turn, right? It's our turn. We are going to do a reverse. We're going to pull these fossil mineralized carbon resources out of the ground, and we're going to burn them and put the carbon dioxide back in the atmosphere. So you can kind of see where this is headed now, right? You getting this now? You're starting to connect the dots. We are now going to send the planet back to where it was when the plants owned it by basically eating them in their mineral form. There wasn't anything at the time they were buried to eat them. There wasn't any animal that could get to them. Maybe there wasn't any animals that could eat them at all. They certainly couldn't get to them. We come along, we're an animal that can eat them. Now, we don't eat them, of course, our machines eat them, but that doesn't matter. Our machines belong to us. They're part of our culture. So we are consuming these dead plants and making up for the fact that at the time they were buried, there was nobody around to eat them. We're changing that situation. In the process, we're also changing the composition of the Earth and its appearance from being a cold, dry planet back in time to when it was warmer from pole to pole, wetter because of all the heat of evaporation happening. The oceans were hot, you evaporate the water, you transport the water vapor, and it rains out somewhere else as precipitation, rain, in the case of a hothouse Earth. So we're going back to that, and we're going back to an Earth that had a lot of trees and not much open ground. So conditions that were better, if that's the right word, for brachiators, right? These guys with the hands, with the curved fingers, right? Swinging through the trees, okay? That kind of a planet, similar to Earth 1.0, and not similar to Earth 2.0, which was the Earth we inherited that encouraged our development as running predators, as chasing predators, organized its troops and tribes, and villages. Yeah. So that's where terraforming comes in. What we're really doing, if you want a word for it, is we're terraforming the Earth. We're terraforming the Earth. We're not terraforming Mars. We're not terraforming Venus. We're not terraforming, Ganymede or any other place. We're terraforming the Earth, but we're going to make it like Earth 1.0. So if we went to Mars and we were saying, let's terraform Mars to be more like Earth, someone might pop up and say, hold on, Which Earth? Well, you know, Earth. There's only one Earth. Ha ha ha. No, 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 no. Throughout Earth's own history, there have been multiple versions of Earth. Okay, so pick one. Which one are you talking about? And so people have to sit back and think, whoa, oh, okay, yeah, you're right. There was snowball Earth. That doesn't sound good. There was hothouse Earth. That might be okay. There was temperate Earth. There was icy Earth. Not quite snowball, but still cold and dry. So which one do you want? And you might pick one and say, this is the one that's closest to Mars, so we can terraform Mars to be like that Earth. And that's a start, okay? So you'd have to pick one. Well, what we are doing now is we are terraforming Earth 2.0, the one we inherited. We are terraforming Earth to be like Earth 1.0, the one that came before us. We're taking things back. I'm calling it Earth 3.0. Now, this is actually how versioning works. Even if you roll back some changes you made in version 2.0, you don't actually call it 1.0. 1.0 is burned. You go 1 to 2. If you don't like what's in 2, you go on to 3. Even if 3 is very similar to 1, that's how you go. And if there's parts of 2 that you want in 3, you keep them. If there's a version 4, it's because things changed again, okay? So we're going forward into version 3.0 of Earth. It's going to look a lot like version 1.0 because we are de facto reversing a process that created Earth 2.0, all right? We are going to reverse that process. We're going to revert that code. We're going to revert that and reversion Earth to 3.0. Terraforming. We're terraforming Earth. Weird, right? It's already Earth. Why would you terraform Earth? Well, guess what? You can do that. You can do that. This Earth has had many versions, of which we have seen only one, version 2.0 in my nomenclature. Maybe Earth 2.0 was actually Earth 6.0. Who knows how many versions there were until we got to the one that we are in now. But if you allow that the version of Earth that the plants occupied when they pretty much had it to themselves, then that was Earth 1.0. The current one with all the ice can be Earth 2.0. And the one we're going to go into, because now we're reverting a lot of changes the plants made, can be Earth 2.0, 3.0. I'll get it right here in a minute. Terraforming. So that's all I want to say about that. We're taking the Earth back. We're taking it back to a time when we didn't exist. It's entirely possible that the reason we exist was because of what happened, that the Earth became dry and cold. That would be hard to argue against, that we are here because of that. Is Earth 3.0 going to be hospitable to us? Well, we have all this technology now. We have lots of machines. We understand the biosphere. We understand plants. Presumably we can carve a place out in the jungle. We can keep the jungle from encroaching on certain places, or maybe we can just live in the jungle the way we live now, right? We just don't brachiate because we can't do that. We got hands like this instead of hands like this. So we're not brachiating, but what the heck? Maybe you can create causeways between the trees, live in the trees like the elves, right? Have causeways that connect them, walk along the catwalks with the actual cats. And so maybe we would do fine. The only question I have is how many actual humans can Earth 3.0, the version we're about to create, support? I don't know, because we don't eat. Our 8 billion people don't survive on a diet of fruits and nuts. There is good caloric content in fruits and nuts, and you could survive on fruits and nuts, but you can survive on fruits and nuts only if you're not competing with 8 billion people. So what are the rest of those people eating? Well, according to the way we do agriculture now, most of the people on Earth are eating some combination of rice, corn, wheat, soybeans, potatoes, yams, okay? Most of what I just mentioned are grasses. Grasses do not grow in the jungle, period. They grow in the savannas. When we left the jungles on our 2 feet with our hands free, full of spears and stones, when we left the jungles and went out on the savannah, we found meat. I want to tell you, meat, okay? And we were meat eaters. We were carnivores, probably for 4 of our 4.5 million years. We were obligate carnivores, and we got big brains, we got big bodies, we got lots of muscle, And, we could tackle mammoths if we had to, right? And that's how we came about. That's how it happened. It did not happen in the forest, swinging from the trees like a chimp. It happened on our feet in the grasslands, chasing bison, or the equivalent. Earth 3.0? I don't know. Good question. Are we going to have those options? If it's wetter and it rains, and it's hotter, it may not be conducive to grasses. Okay, you can grow a lot of fruits in a tropical rainforest. You can grow a lot of nuts and maybe other things, leaves, stems, right? Fern fronds are edible, but that's not how we got to 8 billion at all. That's not how that happened. So will we be 8 billion? No, we won't. How many will we be? 10 million? How many chimps live in the African forest? A couple thousand? 80,000? Maybe 20,000? They're not. I mean, if you don't have any competitors and you have lots of territory to roam around, and you can eat all the fruit off of a tree and then come back a month later and that tree has more fruit. If you can do that, roam around, keep finding places to have food, keep moving on, and you don't run into any other animals like you, they're doing the same thing. If you have kind of huge territories to yourself, then you can do that, right? You can live in the jungle and you can just kind of go around, find the things that they're already eat. But that's not the same at all. What we do, we take a piece of land, we till it, we plant seeds, we harvest the seeds, we have huge caloric availability in these grains. We can then take the grains and feed our domesticated animals, which we don't chase at great risk and expensive energy. You want meat? Throw right over there in the corral. It's over there in the chicken coop. It's out there in the pigsty. Okay, you want meat? Not a problem. But we feed those things grains, and we eat those grains ourselves, and we supplement our diet with meat. And all these kind of things are not really possible on Earth 3.0. Was one outcome, right? It rains too much. It's too hot. It's too wet. It's conducive to rainforest conditions, and the rainforests actually grow really quickly. They could very quickly overwhelm everything that we know today. We could end up in a really, really different world, Earth 3.0, right? And we may look around and say, I don't recognize this place. There's nothing wrong with it. It's very similar to Earth 1.0. So yeah, it's Earth, it's still Earth, but it's not the Earth we inherited. It's not the one that was conducive to our evolution. It's not the one that helped us, find open land and species of plant to domesticate crops and domesticate animals and set up farming in villages. That was not Earth 3.0. That was Earth 2.0. That's a whole different place. So yeah, we're terraforming. We're going to take it back. We're going to take it back 5 million years, 10 million years, 100 million years, who knows? And the conditions will be very different. So I just want to share that, terraforming, how that's what we're doing. It's not even science fiction. It's not even happening on Mars or Venus. It's happening right here. And we're doing it. We are doing that. We are doing that. We're not talking about it. Whatever. Okay, fine. Don't talk about it. Maybe it'll be good. Maybe it'll be great. I don't know. But it'll be different. And that may not be what you want. It may not matter what you want at this point. You may be just going to get it. You're just going to get different, and good luck. Maybe we'll have to go to Mars to get away from jungle Earth, right? We'll go to Mars because it's drier and colder, and it's more like open ground, and you can actually plant. No, we'll terraform Mars, start over, and give this planet up to the jungle. Let the jungle take it back. There you go. Something to look forward to, right?
You want this?